The gas laws are a series of equations that let us predict how changes in pressure, volume, temperature, number of atoms are all going to affect each other, because you can see how they would. Let's look at pressure, volume, temperature. We'll let that be number of moles. So that's the number of particles that we have in our container. All right, let's say that we start off with a certain volume, but then we squeeze that volume down to a much smaller volume. How is that going to affect the pressure of the gas that's trapped inside that container? Well, the particles are going to be hitting the walls a lot more often. They don't have much room to move without hitting a wall. And so as the volume goes down, the pressure is going to go up. How is that going to affect the temperature? Well, this may not be real intuitive, but if you've ever pumped up the tire on your bicycle, you know that the pump gets really hot really fast. These particles bouncing around and slamming into things actually speed up. And so that's going to increase. Well, the number of particles isn't going to change. We're not going to let any more molecules get in or out of this container. What if we took that original volume and let it expand? Well, now the particles have got lots of room to move around. They'll only bump into the walls occasionally. And so as our volume increases, our pressure is going to go down and our temperature is going to go down. Well, what if we add in more particles? So we increase the number of particles. Well, if we increase the number of particles, then that's certainly going to increase the pressure. There's going to be more particles smacking into the containers. If we're in a container that can stretch, maybe a balloon or a syringe, then putting more particles in is going to make the volume increase if it can. And so all these things are affecting each other. Pressure, volume, temperature, and number of moles. If you change one, you're going to make the others change as well. So the gas laws are going to put numbers onto that so that we can predict, if I change the temperature this much, how much is that going to change the pressure? If I change the volume this much, how much is that going to change the temperature? So there's a whole series of these. The first one that we are going to deal with is Boyle's Law, named for Robert Boyle, one of the early investigators. And it deals just with pressure and volume. He was not messing around with temperature or number of moles at all. Now, as long as we have to keep our temperatures expressed in Kelvin, though temperature doesn't occur in this one, then we can use these very simple versions of the equations. Boyle's law, simply stated, says that the first pressure times the first volume is going to be equal to the second pressure times the second volume. So we're looking at our original conditions, that's our condition number 1, and then we're looking at the new conditions, that's condition number 2. So our first pressure times our first volume equals our second pressure times our second volume. And pressure can be in any of the pressure units that we care for. Volume can be in any of the volume units that we care for, though usually we stick to liters just to make life a little simple. So let's try an example. Let's say that we have, alright, as we read through this, we see that we have an original volume in the tank of 18 liters and an original pressure inside the tank of 20 atmospheres. Once we take that air and use it to inflate the balloon, well, the balloon has very flexible sides. It can't resist pressure one way or the other. It's going to expand or contract or whatever it takes until the pressure is 1 atmosphere. Whoops, I've labeled that as a temperature, but that is in fact a pressure. Alright, so our second pressure inside the balloon is going to be 1 atmosphere, and what we've been asked for is the volume of the balloon. So now we've taken this word problem and turned it into a list, which is just so much easier to deal with. All right, we look at these and say, oh, what equation do I know that has these variables in it? Oh, yes, Boyle's Law. So tell me the equation you're going to use, substitute in the numbers, and then you can let your fingers do the walking on the calculator, and you'll find that the second volume will be 360 liters. That's a big balloon. That would be something like 90 gallons. That's a big balloon. But see, it's a very simple and straightforward calculation. And that's because, as we figured out up here, pressure and volume are inversely proportional to each other. And so it makes for a very nice, easy equation. Okay? No muss, no fuss.